Hi there, welcome back here, guys. In this lecture, we have been working with Truffle console. I showed you how you can get an instance of the contract with the Truffle and also with Web3. In this lecture, will continue. This will be AI lecture, so it's free to skip. I just would like to draw some diagrams for you, so I will clear up some things. All right, let's start. I will go immediately into drawing tool, and what I would like to talk about is node. Okay, we have been talking about the nodes in a Ethereum network. Nodes are just simply computers that are running these clients. Okay, they are running clients so they can connect to Ethereum network. Okay, so as I was mentioning, right, we have this Ethereum network connected with the nodes. Connected with the nodes, all right, and they are sharing the same singleton state of entire Ethereum network. All right. Okay, so they're connected together. So in the bigger detail, how the node looks like, it's first of all, it's just simply computer, right? So it's a normal computer. This box will represent your computer. It represent your laptop, your personal computer, whatever. This is a computer. On this computer, when you want to connect to Ethereum, you need to run special clients, some special software. Okay, so on this computer running special client. All right, client. Okay, and these clients, you have a different variety of clients. The most used ones, as I was mentioning before, is a GEF client or parity. The GEF is programmed in a Go language, and parity is in Rust programming language. The part of the client, part of the specification of the client, the part of the implementation of the client is EVM. You will hear this term a lot. The part of this is EVM. Part of this client application is EVM, and EVM is Ethereum virtual machine. Ethereum virtual machine. This part of the application, this EVM, is responsible to take the bytecode and execute it on the node. Okay, so EVM is responsible to take this sequence of the bytes that I was showing you that we are deploying to Ethereum network. That's our smart contract, and the EVM will take the code and will execute it. And if the code will do some changes in the Ethereum state, it will also change the state. And these state changes are applied if the block that has been mined that contains our transaction will be added into the blockchain. Okay, so that's a part of the client. Also, the client have access to the state of the Ethereum. So there is also state of Ethereum, access to the state. And also, of course, to transaction mempool. So transaction mempool. Okay, that's not very clear what I'm writing here, right? So transaction mempool. Okay, so here is a transaction mempool, and there is a set of transactions. So here you have all the transactions that are made, but they are not yet added, all right, into the blocks. Okay, so transaction mempool and the state. State has a following format. State has a one root, and it's a form of the tree. Okay, the state is a form of the tree. It's a form of the Merkle-Patricia tree. This trie. I'll be talking about Merkle-Patricia trees later, but you need to know the state is in this form, the Merkle-Patricia tree. I can write down. Maybe you want to Google it after the lecture. So yeah, this Merkle-Patricia tree. Okay. Patricia tree. Can make a Patricia tree. Okay, so that's basically that's the node running on the computer. Special kind of a software. They have a variety of these softwares. The software also contains EVM, which is an Ethereum virtual machine, which is responsible for executing code. All right, a bytecode. Then you have the part of this node is also state. and also transaction mempool for the types of the nodes that want to mine the transactions and they want to make the blocks from the transactions. And when the blocks are added into the blockchain, then the state is changed for all the other nodes as well. Okay, so this node here, this client is connected with the other nodes as well. Okay, it's connected with the other nodes, and there is a peer-to-peer connection. So here, peer-to-peer connection with the other with other nodes. Okay, so that's the connection with the other nodes. Okay, so this basically here the connection with the other nodes. I don't need to write it right again. All right, so here you have a client. You can ask the questions after the lecture. We'll be talking about this EVM, how does it work later. We'll be also inspecting a bytecode, how it's executed, but that's just what you need to know right now. And also, you have a different types of the clients. Ethereum blockchain is quite huge right now, all right, and it will be just growing. So the state of Ethereum network is quite big. So therefore, you have a different types of the nodes. You have a full nodes. Full nodes that verifying the other blocks transactions, and they're also keeping the entire state. All right, and the state currently, as I'm recording lecture, it should be 900 gigabytes. Okay, it should be 900 gigabytes currently. Then you have a light nodes. Light nodes, they are not keeping the entire blockchain, but they are just keeping informations about the block header. So the size of a light node is much smaller. So they're just verifying the block headers. They're not keeping the entire state, and you can run it easily on your laptops. Later, maybe we will try it out. Okay, so full nodes, light nodes, and also archive nodes. And archive nodes just archiving the state of the blockchain. There is also much to it, but I will include the resource for you here. So full nodes, light nodes, archive nodes. So that's the structure of the node, and let's take a look on the structure of a Truffle now. Okay, so Truffle I will draw, I think, here. Okay, so we are using Truffle. Truffle is a development environment for creating smart contracts. As I mentioned to you, it's built on top of a Web3 API we have been already using, and we have been using it through the console. Right, so we have this Web3 API. It's a middle part of I would say of the Truffle. Okay, so we have a Web3 Web3 API. I'll mark here on the upper side of the Truffle. We have a console. Okay, we have been already using console. Okay, console can communicate with the Web3 API. And through the Web3 API, we have access to our private chain, right? We are accessing our private chain, which is Ganache, right? So private chain, Ganache. Okay, so through the console, the Truffle, we can access the Web3 API, and we can access our private chain. We have been deploying some contracts. We have been calling already functions, and this is the Truffle basically. Okay, so this is basically Truffle. Okay, and here at this upper side, you can imagine as our client. So that's their application. We are running from a terminal. So this will be, let's say this is client. And here we have a network. This downside here. Network. Okay, so we are utilizing Truffle on the client side. We are using console to interact through the Web3 API and to talk with the private chain Ganache. Right? That's how it works. But with the console, the Truffle, the client, we don't have access only to private chain on Ganache, but we can actually talk to nodes on the Ethereum network, to other nodes, to nodes on the live networks. Okay, so we have also this option to go out of the Truffle environment. In Web3 API, we can access also other nodes. Okay, so other Ethereum other Ethereum nodes, and you'll see how we'll do it later. Okay, so that's basically it. That's what we have installed Truffle, and therefore with the Truffle we can communicate with the blockchains. Currently, just with a private one through the Web3 API. We'll be using Web3 API later much more, but this is just from diagram part of the lecture. So keep in mind, note everything is just a software, everything is just a code, and the Truffle for smart contracts. So if you have any questions on these diagrams, I will send you some links in the resource of this lecture. Let's continue, guys, in the next one. Cheers.